Welcome to Black Adam. We have chemistry class and we have innate ionic equation. We need to balance it and then determine if we have gas. And we have cadmium sulfide. We write that CD S, which is solid, and then that reacts with aqueous, which is sulfuric acid in aqueous form. That is H2SO4, and which is aqueous, so that is aqueous format, and that will give us that reacts with that cadmium reacts with sulfate to give us cadmium sulfate, and that has got to be aqueous, and we have hydrogen reacting with sulfur, so that will give us hydrogen sulfate. Okay, so hydrogen sulfate, so that has to be gas. So hydrogen sulfate in most cases is gas. And okay, that we have solid there, and then it's balancing, everything is balancing, and which means our equation is balanced. Now from there we know that hydrogen balances, oxygen as well balances, and then we have sulfuric acid, that is a strong electrolyte, so which means it dissolves completely in water, and so that's Se for strong electrolyte, so that is also strong electrolyte, Se. And we write the equation above, and then we break the strong electrolytes into the ionic form, into the charge form. So that would be 2 hydrogen charge, which is plus, and then we have sulfate ion, okay, ionic there, and then we also have cadmium ion, and then in ionic form, and sulfate also in aqueous, that's ionic form. And then we have hydrogen sulfate, which is gas. So now we cancel the common part, the sulfate cancels on both sides, and now we are left with the innate equation, which is cadmium sulfate plus hydrogen ion, which is in aqueous form, and then that is cadmium ion there in aqueous form, and plus hydrogen sulfate, which is in gas form. So that's our gas. So that is our first example, and then we have another example. So the gas is hydrogen sulfate, molecular formula, innate equation, and that's all we require to do. So the second one, we do the same thing for magnesium carbonate. So that's MgCO3, and that's solid there. So that's solid and reacts with perchloric acid. So perchloric, that is H, and then that is chloride, and then 4 oxygen, so O4 aqueous. That reacts to give us that reacts with that magnesium chlorate, and then that means that will give us magnesium chlorate, which is aqueous. Yeah, it's 2 there, which is aqueous. And then we have hydrogen and carbonate. So that's interesting, because the H will react with one of the O's there, giving water, which is liquid. And then we have -1 oxygen from carbonate, and we have carbon dioxide left. So that's carbon dioxide, that will be gas. So most carbon dioxide in most cases is gas, so that's 2 there, and that there is strong electrolyte, and that's also strong electrolyte. So in most cases strong electrolytes are found in aqueous form, so that's aqueous there. So we have magnesium carbonate solid, reacts with. So we break down, so it's going to be hydrogen plus aqueous. We can balance it later, and then that's plus chlorate, which is negative charged, and then we have magnesium, which is 2 plus in aqueous form, and then we have chlorate, 2 of them, 2 chlorate, which is negative charged in aqueous form, and then we have, okay, so let's check. Okay, we have water, H2O, which is liquid, and then we have carbon dioxide, which is gas. And when we check, it's 2 there and 2 there, so that's negative charge that balances. So chlorate found on both sides, so they cancel out, so our Nate equation is going to be magnesium carbonate, which is solid, and then we have 2 hydrogen ion, which is aqueous, and then that gives us magnesium ion 2 plus aqueous form, and then we have water, H2O, which is liquid, and then we have carbon dioxide, which is gas. And then yeah, so that's our answer for the second attempt. So now I have homework for you, so let's use your homework. You can go through that. You have to write the balanced molecular formula, ionic Nate equation, neutralization reaction, aqueous, acetic acid, barium, and so forth. Thank you for watching. Don't forget to follow, subscribe.